Hello, my name is Bertrand, and welcome to another episode of PowerEdge Soundbites. So welcome everybody, and today I am joined by Fabricio. Fabricio, why don't you introduce yourself very quickly before we get into our main topic today, which is going to be the NVIDIA Inference Microservices, also known as NIM. So yeah, Fabricio, why don't you give a quick intro of who you are and where you fit within Dell?
Hi, Bertrand. As you mentioned, my name is Fabricio. I'm part of Dell since 2009, and I'm working on the integrated solutions engineering. I'm working developing and testing all the GenAI solutions that we have published, and I'm happy to be here and discuss about NIMs.
Cool, awesome. So at GTC a few weeks ago, NVIDIA came out with this solution called NVIDIA Inference Microservices, or NIM. Can you give me a quick kind of overview of what NIMs are? And I mean, is NIM one thing? Do we have multiple NIMs, or what is included into a NIM? Can you kind of give us a bit of an overview of that?
Of course, NIMs is an idea that came from NVIDIA to provide a curated group of a container running the service that uses mainly the Triton inference server. Also, the model that's better configured and optimized to run on NVIDIA GPUs. And also an API, industry standard API to send the requests for the model. So the way that they created it basically provides an easy way or easy step to deploy any model that is included on NIM. Nowadays, the version available and supported is the NIM for LLMs that focus on Llama 3, 8 billion and 70 billion parameters. They also have some testing or some pre-GA versions for biology, for medical images, and for several other areas, and they will start going to supported versions in the future. But it's a good way to test, and it's even available on NVIDIA portal to test it online.
Cool. I think it's interesting that NVIDIA has decided to take that route, because when we think about prior to the introduction of NIMs, I mean, as somebody who wants to try inference, I had to, as you said, I had to download the Triton server. I had to spin it up. I had to, download the model. I had to put together an API server so that I can actually interact with the server. And all of this takes time and effort. Whereas in NIM, it sounds like NVIDIA has packaged everything into a super simple deployment model, so that if I need to spin something up quickly, I can. Is that a fair assessment?
Sure, it's a perfect assessment, and to be more complicated, many times the model and the container was in different places. Like you need to download the container from MGC, and you need to download the model from Hugging Face. You need to convert the model to be able to run on Triton. So was possible to do, but the way that NVIDIA is providing now, it's a really easiest way to do that.
That's awesome. And it's interesting that I'm sure some listener might wonder why start with inference. And I think the rationale behind this is that when we look at the use cases that our customers are implementing, inference is probably 90%, 95% of them, and so automating and making it easier to spin up those workload is to me is great value to our customer. Do you agree with me?
Exactly, and these can be the base of other applications. Like you can build a RAG solution, use the NIM using the LLM as your backend. You can do other things like summarization or any application that requires a LLM as backend will be ready to use. So you can basically build up this NIM application with just one command.
Cool. One last question before we get into the demo, because you've got a bit of a demo for us. You said that NIMs are based on containers. What platforms do they run on today? I mean, Docker, Kubernetes, what platforms?
It was initially available on Docker, so the easiest way today is running Docker. But NVIDIA is also working on a Helm chart, so you'll be able to run on Kubernetes very soon. Actually, it's available already. We have a GitHub repository with a initial version to run this. But in short time, will be available in the supported version also to run on Kubernetes.
That's awesome, because I mean, as we know, a lot of our customers are using Kubernetes, and so for their container orchestration platform, and so having it available on Kubernetes is a big plus. But it sounds like today, it's pretty easy with Docker to spin it up.
Sure, it's very, very easy, and even if you just want to take the steps and put in your flow to run on Kubernetes is not complicated at all.
Cool. Why don't you show us how easy it is?
Sure. Let's go there.
All right, I can see your H100s and your prompt, so we're good to go.
Great. So this is the knowledge as the beast, the XE9680. It has 8 H100s with 80 gigabytes of memory. The 8 GPUs here, there is nothing running, as you can see here. And I will leave this screen here so we can see what's happening. So to basically run the command, we have to set the container name, the credentials, the name of the image, but basically what we need to run is this single command. This Docker command, we will start the command. Here I will be starting the 70 billion. So when it starts, it shows what is the model that you are running. It shows some options that you can run, like NVIDIA calls it profiles. I will give more details on that, but there is some profiles that the container detects that are supported based on my hardware. And then select the best one for starting the service, the model. It downloads all the files if I don't have locally. So to be faster, I already downloaded the files and have his running here in a faster pace. But it basically, if the first time that you are running, if you just run this command, it will do everything, and after a few minutes, it will be ready to use. So here we have the profile that it's selected. So as we have 8 GPUs available, it selected the best one with the lower latency using 8 GPUs. The model GPUs is the H100. The engine that uses is the TensorRT LLM. We also have VLLM available to use if needed or if wanted, and the float point 8 FP8 for the precision. And as you can see here, the memory is started loading with the model, and in just a couple minutes, it will be ready to submit inferences. One good thing here is we have NVIDIA adopted the OpenAI API, so it's very easy to, instead of use ChatGPT, test with Llama 3 and in just a couple changes in the code. So here is the screen that it shows how what are the endpoints available. It submits a simple request just to make sure it's working, and as I'm using Docker, it's pointing to the 000 IP, but I can configure to use the IP. On my case, I'm using Docker with the host network. So
one thing I want to say is, at the beginning you talked about some authentication and various parameters. I should mention that you and I have collaborated on a blog that will be posted on InfoHub. I'll put the link in the video in the description of the video, and that blog goes into a little bit more details on how to get your NGC API key and what the various parameter in the Docker command, what those parameters are. I love the concept of profile, and I'm happy that we're gonna dive into it a little bit later. Yeah.
That's perfect. It's good to mention that to keep the demo a little short, the best place to really get deeper, detailed information will be our blog.
Exactly.
So here we have already the model running, and we can submit any request. So here is an example. Let me get the. This is the way that the model or the OpenAPI API need to receive the request. So we have this format, and I just need to select here the right model. Here I was doing some testing with the 8 billion also. So, but here it gives some instruction on how the model need to behave, and give the question. So in that case, a Python code how to import a CSV file using Python. So the answer is here. It's a little bit complicated to read. If we do the same thing with a more short answer, like if I write, what's the capital of Texas?
Well, and I think it's interesting that NVIDIA has gone with the OpenAPI or the OpenAI API because, as you say, there's a lot of our customers are implementing application based on ChatGPT and are using the OpenAI API and are very familiar with the OpenAI API. And so having that common standard, I think, makes it super easy to transfer from. I'm doing a POC with ChatGPT because it's super easy I am now hosting this on my own hardware in my own data center, and I actually don't have to change the application that is talking to the LLM because it's all OpenAI API. So that's super smart.
Yeah. Basically, you just need to point to change the direction. Instead of pointing to the ChatGPT's website, we point to your own IP or host name.
Exactly.
To make the visualization better, I created a very simple code here that you use the same API, but they will translate in a easier way to see the answer. So this is the same question that we had previously.
Yeah.
But you see that the format is much better, so I can read better.
I can read that.
Yeah, that make more sense. So we can use that to really create things, or even if I write the same thing about Austin, or sorry, about Texas, that the answer is Austin. So the capital of Texas. So it's very easy to manage and work with. And we even have some tools. NVIDIA provide one tool that's the GenAI Perf, that's based on the Triton model analyzer. It will be covered in a future blog that we are working. So I will not give any more details on that. I will just show what happened. But this basically will submit requests to the model. Here will be 100 prompts with the input of 100 tokens and output of 100 token. And it will generate automatically the profile of the answer. So time to first token, the latency for receiving is the latency between tokens, the total throughput that the model receives. So it's also easy to evaluate how good is your performance in your environment. Selecting different profiles, for example, verify which one is better for your application. As you can see here, very easily, it provides very good information about the average of the latency, mean, max, P99, P9, P75, the total throughput. You can increase the concurrence of the requests, like to 10 simultaneous concurrence. You see that the throughput will increase. So it's provide all the tools, not only to deploy, but also to make sure that your environment is working on the best performance possible.
I also saw that the utilization on the GPUs has shot up as soon as you started that.
Yeah, that's a really way to see that the GPU are being used at maximum.
Yeah.
So it's a good way. And if you select a profile like that use only 4 GPUs, for example, you'll be able to see 4 GPUs working and 4 GPUs idle. So it's very good. Like here we can see that the latency increased a little bit, but also the throughput increase it. So you can have this kind of evaluation of the model.
Cool. Why don't we dive into profiles then from now?
Sure. Let me stop here. I'll get the profile command. Just 1 second. So this is the command, also a simple command to run the profile. It will start the same container, but instead of downloading and starting the model, it will show all the profiles available. So on this case, I'm running for the 7th billion. It lists the GPUs that are free and available to use. And this is the profiles that it compatible and can be run. So I can select any one of those profiles and run.
Interesting.
Those ones are supported with LoRa. So I can use NIM and have a LoRa with my own fine-tuned model to run my application. So I can use NIMO, run the path with LoRa. It creates a small model and work combined with the llama tree. It's totally possible to do.
Okay.
And the incompatible models that are based in different GPUs, like the L40S or A100. If I'm using another model or server with that GPUs, with L4S, for example, the answer will be different. The supported one will be the L4S. So it's very easy to run.
And it's interesting that you can select. It's interesting that you can select a profile for fine tuning / customization as well. So that's super cool. Because I mean, let's face it, 95% of the use cases are inferencing. Another probably 4% are going to be customization or fine tuning, and then 1% is going to be training. So really, by having those profiles, NVIDIA is addressing probably 99% of the use cases out there.
Sure. And the 1% that's not covered, we still have the Triton with the manual process. So that's cover everything from NVIDIA side and can use it.
100%.
So, for example, if we want to test the VLLM, I can add this parameter here, put the ID of the configuration, and
Mm-hmm.
run. That's it. It will understand that I want a specific version or a specific profile, and will deploy. As you can see
Yeah.
here, it's already detected that a VLLM is not the TensorRT anymore. It's FP16, not FP8 as
FP8.
previous version, and it will do the same thing. And the way to test it will be the same thing because the API is the same. So I can submit the same request even using VLLM instead of TensorRT, and so it's very very easy to use.
That is super cool because in talking to customer, I've been having quite a few questions on what should we use? Should we use TensorRT LLM? Should we use VLLM? Which one is it going to perform better? And my answer, unfortunately, is a lot of the time kind of it depends on your use case, and being able to do a quick test, being able to do a quick performance test on the hardware with TensorRT and then with VLM is super useful for customers because it allows them to, again, based on their use case, to figure out what the best framework to use is.
Sure, and that's just a simple command to change. So it's
Yeah.
very easy to change it. I had a quick disconnection here.
Sure.
Let me share again.
There you go.
So it's still loading here.
Yeah, and the fact that the API, basically the API server is the same, whether you use TensorRT LLM or whether you use VLLM, make that testing super easy because you're basically running the exact same command. And if you're using the GenAI perf tool that you showed before, you can run the exact same command against it and see what your time to first token, your latency, your throughput, and all of this, see how they differ between the two, and then make the informed decision of what's going to be working best for you.
Exactly. And if you set the IPs, for example, you can even have TensorRT LLM running on 4 GPUs and the VLLM running on the other 4 GPUs, or one running one server and the other one in other server, and having this differentiation at the start, or like testing the difference of the 70 billion with 8 billion. You can have one running on part of the GPUs and the other running on the other part of the GPUs, and have interactions and comparing answers as you need.
That is so for me, that is super powerful because again, when we talk to customer and customers ask us questions, a lot of our answers are really depends because experimentation in the space of Gen AI is really key. And so I think what you're saying here is that if I'm, if I want to experiment, as you said, I've got 8 GPUs on my 9680. I can call 4 for VLM, 4 for TensorRT, and see between the two. Or if I'm not sure whether I want to run 8 billion versus 70 billion, I can call 4 for 8 billion, 4 for 70 billion, see what different answers I get, and figure out which one is most appropriate for me. And then I can mix and match all of those combination and all of those permutation. And it's as easy as basically running the same command and changing a couple of things when we're running the command, which is super cool. I gotta admit, I totally see the value that it brings.
That's perfect. And testing different FPs and
yes.
And for sure, NVIDIA, this is the release 1.0, so it's the first, it's the beginning only. This will increase a lot. And just to complement the demo, we have now the module loaded, and I will go to Micro and submit the exactly same thing, or we can submit the question manually. And it's just work. So it's really the same API, same thing. No matter if I'm running TensorRT LLM or if I'm using VLLM, both will work with no problem.
That's awesome. That's awesome. As I said, I think, you know, a lot of our customers are using ChatGPT to start their journey because it's easy, because you just have to, you know, do curl, or you just have to submit API requests to it. But ChatGPT is not inexpensive, and being able to run and being able to experiment all of this on-prem is in such an easy way, where you can try the different permutation. You can try, you know, FP16 versus FP8. You can try, you know, VLM versus TensorRT LLM. And you can try 8 billion versus 70 billion in such an easy way. To me, is super powerful.
Agree. 100% agree.
Cool. Any last thoughts on NIM before we close out?
Just say that all the Dell hardware are ready to run XE9680 or R76XA or XE8640, whatever is the option of the customer. Our systems are validated for that and can run on our Dell AI factory with no problem.
And you showed it as part of the demo when you can select the profile. I mean, we use the H100s, but you showed that they are profiled with L40S. So if customers want to do a 760XA with you know, a bunch of L40S, we can totally support that. And as you said, the fact that all of this can be integrated into the Dell AI factory, I think is key and super critical. So Fabricio, thank you so much for your time today. Thank you for the demo. I think this is gonna tremendously help our customers' journey into the Gen AI and help our customer with their experimentation to get the best value out of Gen AI. So thank you for the demo, and have a good rest of your day.
Thank you, Bertrand. Have a good rest of the day for you too.
Thanks. Bye.
Bye.